Lesson 7 is on comparing linear functions and graphs. So there's lots of different ways we can write linear functions. For example, some of the ways. We can write it as an equation, right? That's what we've been doing. We can write it as equations. We can write them, can write as a table, kind of like down here. This represents a linear function. We could write it, we could graph it. And sometimes it's just given to us in a written description. So when we're talking about linear functions and we're talking about comparing them, what happens if we're comparing them and they're written in one of these different forms? Okay, so that's what we're working on today. So let's look at this first example. You've recently begun researching phone billing plans. Yeah, this happens, right? Phone company A charges a flat rate of $75 per month. A flat rate means your bill will be $75 no matter what, okay? No matter how much you talk or text or anything. But the billing plan for company B is a linear function of the number of texts that you send each month, okay? So we know it's a linear function, and it's going to be based on how many texts you send. So the total bill is going to change depending on how many texts you send. So, excuse me, this represents company B here. Company B, if you send 50 texts, it's going to cost you $50. If you send 150 texts, it's going to cost you $60. Remember, these are our input values and our output values. So these are X values and Y values. So we want to know eventually here, at what number of texts would the bill be the same? Okay, at what number is it better to have company A? At what number of texts is it better to have company B? So you're making an informed decision. Okay, so we have two companies we're choosing from here. Company A is really easy. Our outputs here, the number of dollars, right? Cost is going to be $75. Why is cost? Because it says right here, you're paying $75, doesn't matter what, okay? But company B, we need to figure out their equation. We already have an equation for Y. We're not multiplying by any X values because it's not changing. It's staying constant. $75 no matter what. So this is a good review now of how we can take numbers out of a table and we can write an equation. Now, the key word here is a linear function. So I'm not asking. I don't have to find the slope between each point. I'm told it's linear. I know it has to have the same slope, the same rate, this however you want to think of it. So I'm just going to pick 2 points. And I'm just going to pick these first 2 points here. This is the point 50, 50. And then I'll take the second one here. And this is the point 150 and 60. This is my X value. This is my Y. This is my X value. This is my Y. So remember, to write an equation, we need to find the slope and then find the y-intercept. Okay. So my slope is the difference in my y's, y sub 2 minus y sub 1 over the difference in my x's, x sub 2 minus x sub 1. And since I've identified my point here, I'm just going to make one the first point and one the second point. And then I'm just going to plug it in. Okay, these are minus signs here. So y2 is 60 minus y1, which is 50. And then I have x2 minus x1. x2 is 150 minus x1, which is just 50. And this works out to be 10 hundredths, or if you divide that out, it's 0.10. 10 hundredths, 1/10. So I know my m is equal to, and I'm going to say 0.10, just because they're kind of talking about money. And that's basically coming down to 10 cents per minute. Now, remember, to write an equation in y equals mx plus b form, I have my m, I don't know what my b is, so I need a point. And I'm going to use actually the second point just so my x and y aren't different. So I'm going to take the point 150, and you can use any of the points, remember. This is my x value, this is my y value. I have an x and a y and m. I'm going to plug that all in and figure out what my b is, my initial value. So y I'm going to say is 60 equals to m 0.10 times, I'm putting in parentheses here, times my x, which is 150. Fill all that in, and then plus b. So now I'm just going to solve for b. So I get 60 equals, if I go 0.1 or 0.10 here times 150, that's 15 plus B. I'm going to subtract 15 from each side. And I'm going to get 45. So B equals 45. So our equation, remember, after all of this, okay, is y equals our slope, which is 10 cents per minute, 0.10, times our input values, x, plus 45. Okay. So we're paying $45, okay, plus additional 10 cents per minute because, well, I'm just going to leave blue here. Remember the B. Ooh, that was bad. Try that again. Okay, whatever's being added on, that's our initial value. That's our initial value. So we have this equation here now, and now we can go up here, and it says, hey, at what number of techs will the bill be the same? At what number of techs are these two going to equal each other? Is company A going to equal company B? Solve the equation. So I'm solving for x. I'm going to get rid of the 45 by subtracting 45 from each side. That's 30 equals 0.10x. That cancels. Divide both sides by 0.10. And I'm going to switch around here and we get x equals 300. Well, what does x represent? The number of techs. So at 300 techs, it's the same. It doesn't matter what plan you pick. If you send 300 techs, you're going to be the same. Okay? So what happens if you send 301? Okay? So let's do that right here. Let's take our equation and let's put in 301 techs. 0.10 times 301 plus 45. And if I'm just going to grab a calculator here and type that in, and I get y equals 75.1. So I'm going to say 75.10, $75.10. So at 300 techs, I'm sorry, 301 techs, company B becomes 10 cents more. Okay, so my guess, not my guess, if we were to do 299 techs, and I grab my trusty calculator here, that would be $74.90. All right. So that 300 is the cutoff point. If you're going to send less than 300, company B is the better deal. But if you're going to send more than 300, company A is the better deal. So that's just kind of the things you need to do as you're looking at cell phone plans and other different types of plans. But also, all this information came from by comparing a written description for a phone company plus a table. Just dealing with functions in different forms.